Hi, my name is Alex Williams, founder of the New Stack, and you're listening to the New Stack Analyst Podcast, a show about application, development, and management at scale. Thanks for joining us. Thanks to Cisco for sponsoring this episode of the New Stack Analyst and our continuing coverage in advance of KubeCon, the conference for the Kubernetes community happening in Seattle this November. Check out Mantle, the open source microservices infrastructure. Mantle runs containers on any cloud service, integrates data platforms such as Cassandra, Spark, and Hadoop, provides ways to deploy and manage infrastructure with tools such as Terraform and Ansible. Learn more at mantle.io. That's MANTL.io. Please also join us for podcasts, Pancakes, and Robots for our Pancake Delect Pancake Breakfast on November 9th at the KubeCon conference. Thanks to Cisco again for making it possible. Hey, it's Alex Williams of the New Stack here for another episode of the New Stack Analyst, here with my co-host Joab Jackson. Hey, Joab.
Hello.
And we have two guests with us today. We have Mr. Ken Owens. Hey, Ken.
Hey, Alex and Joe. Good to be with you guys again.
Ken is with Cisco, and he's very involved in the Mantle project, and so I'd like to talk a little bit about that. And we have Somik Behera. Hey, Somik, how are you?
Hey, Alex. How's it going?
Good. And Somik is with Mesosphere. And one of the topics that we just covered in our ebook on the Docker and container ecosystems on networking, security, and storage. And it was at ContainerCon, and I did a pancake breakfast panel, and we were talking about open standards and where the community is moving, and what's going to be, how we're going to really maintain this infrastructure that's reliable and boring, as some people like to say. And one of the topics that came up was CNI. And so I thought we would focus on like this whole idea of the new networking, what is emerging as some of the quote unquote standards of the industry. And so I thought, for our purposes, perhaps we could start by helping us understand what does it mean to configure a network interface for Linux containers. And perhaps either you guys, you can speak up if you feel more comfortable with the question.
Sure, I'd be happy to start, Alex. So, when you think about containers and this sort of I could call cloud native, this new cloud native model for developing, you're taking an application and you're breaking that application into smaller components that we call containers, right? And so when you think about an application, it's a set of services that consist of a set of containers, if you will. And so in order for an application to be accessed by someone, it needs an interface, a network interface that allows people to access it and go to it, right? And so the main reason you need a network interface is you need the ability to communicate and send information, receive information, and sort of specify the types of rules and policies around which governance and security can be adhered to within these sort of like containerized environments.
Somik, would you add anything to that?
Yeah, I mean, I would take a different approach. By the way of my background, I was an early engineer at VMware, early product manager for Nicira, founder of the OpenStack Neutron project. And we struggle with these kind of questions in the early infrastructure service realm is, how can you make compute infrastructure programmatic? That's where OpenStack Neutron and a lot of these on-demand virtual networking technology came in. And now that we have gone into containerized environments, imagine the density that happened with virtualization has gone up an order of magnitude. So what we did with virtualization is we created what VNICs or virtual network interfaces, and they became the standard for how you give network access to a particular virtual machine. Now you can have thousands of containers on a single machine. Sometimes these are running inside the virtual machines, and sometimes natively on bare metal. So that technique of giving a VNIC per container does not really scale in a containerized environment, a complete network namespace. So in a containerized network environment, folks, what they started doing was sharing the host's namespace. So just one NIC, everybody gets a few ports from that NIC, because there's kind of limits on how many kind of NICs you can have in the system. And what CNI and a lot of these techniques are coming along is to create a standard way for a container to interface with a network subsystem, be it a VNIC or a NIC kind of model, or a bridge, or a VET, or shared host networking, or some kind of virtualized infrastructure.
Excellent. So what is the difference between the container networking model and the container networking interface?
Good question, Alex. I'll take my first stab at it. The big differences between container network interface, CNI, and container network model, CNM, is CNI is kind of, first of all, is very agnostic to implementation technology. It's host local specification, specification of an API, where, if you will, the rubber meets the road, right? Like it is on every host. When a container comes up, a point in the life cycle, the container can attach to quote unquote something network. We don't know. It's very unopinionated, right? And supported by a variety of vendors, including the Kubernetes community, the CNCF foundations, the AppC and Spec and Cloud Foundry Foundation, as well as the Mesos and the DCOS communities. CNM, on the other hand, is a container network model, very similar to what I did in my previous gig when I created the Neutron project. It's very similar to creating an abstraction of networks, of ports, and an API layer, how you can map to a container to a particular port and a particular virtual network, or any kind of network, CNM network. So it takes an opinionated approach. Today, it's the evolution of the libnetwork project proposed by Docker, and the ecosystem around that is very Docker-centric. And the number of people who support it is limited, and it's a little more rigid, because that kind of model, I did it, they were meant for a different era. And while CNI gives you a very flexible schema to do whatever you want to do with it.
Now, I guess I'm still back in the Stone Ages when it comes to network administration. I guess you can't run containers under the standard Linux network model of an IP number and a port address, a combination of those two?
Joab, yeah, you can definitely run containers in the existing Linux host namespaces. That is the default way people run containers today. You share the entire host namespace, and container is just another application, if you will.
Yeah,
exactly. The other interesting thing between the two is, like, when I look at CNI, it's very similar to the way you would expect networking to work with the IPAM, IP management components that we just talked about. It has gateways and destinations and routes in them. It understands DNS and namespaces, right? And so it's much more in line with sort of the way networking should work in any environment, whether you're containerizing it or not. And it's a very easy and logical fit for network admins and for developers that are familiar with Linux networking already. Whereas libnetwork is sort of more of a lifecycle model, and then it's much more abstracted, as kind of talked about already, in terms of like just create and delete and join and leave. It's not really network speak. It's really more of a overlay model around bridging technologies together, which is not, I think, as familiar with network admins, and definitely, in my opinion, not as familiar for developers who are used to Linux networking.
Is that what you mean by lifecycle then? What's your just the create?
Correct. Yeah, the create, the delete, the join, leave.
CNI is not a network overlay technology.
Definitely.
CNI has some network overlay capabilities, but it also has some like specific, basic IP address management and routing as well.
So, Joab, so CNI is really a spec of what a container can expect from its host. And it effectively, the spec says, if you look at the spec, it says network kind of name, where you want to connect it to. What type is it? Like it needs to be serviced by some third-party binary called plugin. One of the default shipped plugin is a bridge plugin. So then it will just connect it to a bridge. And bridge plugin might need a particular bridge you want the container to be connected to. And you specify that in the CNI configuration file. And based on that, when a container orchestrator like Kubernetes or DCOS comes into play, and they try to launch the container, they will look at this config and kind of invoke the right CNI plugin and let it kind of do the networking. All the orchestrator will do is effectively manage a compute element, container lifecycle, and create a network namespace if needed. And then this plugin, network plus CNI plugin, can do anything it wants with that namespace. It can bridge it, it can create a VET and attach it, it can create an overlay or plug it in, or call out to a remote controller to do some magic around network virtualization, if you will.
Excellent, excellent. So it's the orchestrator, the Kubernetes or the Mesos that is actually acting as, I guess you would call it the master node, so to speak. It has the complete internal view of the container network.
Correct. It has the global view, and the CNI is like a host local view, yeah.
Does it have a node view down to the node itself?
The orchestrator needs to specify, so you need to have these CNI networks or CNI configuration pre-populated on every node before you launch a container. And then when you launch a container, the user is going to has to specify which CNI network they want to attach to. Now, it has the node view in that it can create a node view, but it does not as natively have a node view. Basically, which are the CNI networks on every node.
Yeah, I hear Docker talk about node identity, right? And and their philosophy about cryptography, right? Mm-hmm. And they talk about it in the context of this networking environment. What's the parallel to what you're describing?
So in our world, from a network perspective, there won't be a parallel, but from an identity perspective, every node, I'll speak to DCOS and Mesos first, right? So in DCOS and Mesos world, every node is an agent node. It has an identity in that it has a service account, if you use the DCOS parlance, where every node is provisioned with their own kind of service account, and they use that to authenticate and connect to the master node so that they can take instructions from the master node around doing container orchestration and lifecycle management of a container. So that's where the identity in Kubernetes has a similar concept. The kubelets, which will join the controllers or the individual node, but it does not have any kind of security built in. But every node has an identity. You can join to a controller, and the controller can schedule workloads on that particular node.
Ken, from our perspective, so what does this mean for the end user? I mean, in terms of their own understanding of these networking capabilities. One of the things that we are hearing discussed more often is the complexity is moving into the orchestration environment itself. And abstracting out the, that complexity. So, someone who may be a developer, but also is involved in the ops world, can actually use these technologies. I'm curious on the user experience and how these correlate, for instance, CNI versus CNM.
Yes, I mean, there's a couple of, I can talk about a couple of different user perspectives, right? And so from in my mind, they're both sort of overly complex in terms of the way cloud native and this whole microservices approach is going to be going. So I think, my view is that the networking in the container space, and for that matter, even like security, are going to drastically change from the way we think about network and security going forward. I'll get more to that in a few minutes, but specifically to like the users, it's pretty complicated today to have to remember to install a plugin and then go in and configure the type of plugin and the path, the namespace path, and then go into configuration, make your configurations. And if for some reason you didn't have the right port or didn't guess the right, IP address, or you overlapping IP address, there's nothing that really tells you that, right? It's trial and error to figure these things out. And so for a network administrator, though, this is something that they're, especially with the CNI, they're familiar with this type of configuration. And so it really makes when you're a network administrator, it helps you sort of understand containerization and what the impact of containers are in your networking space a little bit more common, because it's very similar and familiar to you. If you're a developer, though, which is what your question was around, and my view has always been the developers just want to have the network just do what the network needs to do, right? Just figure out what port I'm opening and just opening up the rules to allow that port to communicate to the other services I need to communicate with. And I think that's where you're hearing some of the concerns and complexity from the network, from the development teams, because it is very complicated to try to figure out which IP address range you can be on, which, if you're using CNM, it's very confusing to figure out if you're, which group you want to put your services into, right? Your interfaces into. And so there's a lot that's being pushed now to the developers to figure out in the network. And I don't think you really want your developers thinking about network as they're writing applications. I mean, it's not bad to understand things about the network, but I don't know if it's the best use of a developer's time to try to figure out what IP addresses and ports to use.
Let's take a quick break and get back to the show. Thanks to Cisco for sponsoring this episode of the new Stack Analysts and our continuing coverage in advance of KubeCon, the conference for the Kubernetes community happening in Seattle this November. Check out Mantle, the open source microservices infrastructure. Mantle runs containers on any cloud service, integrates data platforms such as Cassandra, Spark, and Hadoop. It provides ways to deploy and manage infrastructure with tools such as Terraform and Ansible. Learn more at mantle.io. That's MANTL.io. Please also join us for podcasts, Pancakes, and Robots for our Pancake Delect Pancake Breakfast on November 9th at the KubeCon conference. Thanks to Cisco again for making it possible. You mentioned plugins and plugin architectures, and there was a lot of talk about plugin architectures. I remember them, 2015, there was, DockerCon Europe, and it came out of DockerCon Europe. There was a lot of discussions about plugins. What is the state of the plugin ecosystem now? Is it stalled? Is it, where are we now? Is it thriving? What are some of the things that are affecting the evolution of this concept?
I think probably the biggest impact to this ecosystem growing is sort of the traditional and legacy networking controls that are in place today and tools for managing networking today. I think there's a lot, as we mentioned earlier, that's very common with Linux, just Linux host capabilities that are very common, but there's also a lot of differences now when you think about these services being spun up in different hosts, and how do you connect those services together in a way that allows them to get the right level of performance and the right level of security and assurance that they need. And I think when you look at the more complicated or complex aspects of what an application really needs to be performant, that's when I think a lot of the overlay and the plugin models start to suffer, because you're already taking something like Linux networking that wasn't designed to be very high performant, and you're trying to get it to do a lot more than it was really designed to do, if that makes sense. And I think some of the plugin architecture is just adding another layer of of overhead to that already low performing sort of model?
I would say depends on plugin ecosystem in which model. In CNI model, it's a very thin shim layer. So there is no kind of performance overhead. It depends on what the plugin is doing. And the CNI plugin ecosystem is thriving pretty good. There were early CNM or the lib network plugins. There were a few of them. But now we see more and more folks jump on CNI, and practically because from a network vendor perspective, right? If I'm a networking, be it an overlay technology provider, like, Contrail, or be it, Cisco, the Contif project, or be it configuring the routing tables on every host node like Calico. All of them, if it's what CNI gives them is that ability to integrate to this one standard and write one plugin, and which works across Kubernetes, Mesos, DCOS, and multiple different orchestrators. So that's what's kind of rejiggered, if you will, the network plugin ecosystems with the CNI movement kind of coalescing.
Definitely much more rich ecosystem with CNI than with CNM, which is mostly just Docker.
Why is that? What's happening in the community there?
All the things that we've touched on, right? It's the ability to do multiple types of orchestration, multiple types of network. Easy plug-in to get your network up and running quickly, and it's more aligned with how networking admins think about and how even developers think about networking in general. So I think it's just all of those different components together, make a very strong case to look at CNI as sort of the starting point for basic networking.
I'm kind of curious from the system administrator's point of view that might have a number of containers already in production and they're getting ready and they want to move off of CNM. What exactly is involved in shifting over to CNI? I mean, I know there's like Calico and Weave, but does this mean outfitting all the containers with a shim? What is the deployment? Yeah.
So practically speaking, I can speak to that. So there are multiple waves. You can create a transitional path. Obviously, you'll have to do some work if you are to do a kind of seamless transition. But practically speaking, what you would need is an orchestrator which supports CNI standard.
Sure.
Then you need a CNI plugin provider.
Mm-hmm.
The step 3 you do is you create a CNI network using that CNI plugin provider. For example, let's call it red, green, blue, 3 networks I had. So if I do CNI network create red, CNI network create green, CNI network create blue. And when you do that, what happens is that for every of these networks, there is a configuration file, a CNI network configuration file. That file gets placed on every node in your environment. There is talk as part of the CNI community to have this configuration distribution service, but today you will use to place that file and this plugin binary and start the binary up, whatever the plugin binary is, with the CNI configuration file for red, green, blue network, right? Mm-hmm. Then the transition step, the easiest transition step would be you shut down your existing Docker container and you'll relaunch the same container using one of the orchestrators and give it a parameter, say CNI, join CNI red network, or CNI green network, or blue network.
Is this the concept? Is this the concept of the interface container then?
Yeah. I mean, effectively, when you give that information, when you launch, the orchestrator gives it when it's launching the container, that particular red network is plumbed to this. Its interface is plumbed through invoking a CNI plugin.
So what do we have? So what's coming up? So we have KubeCon coming up, and we'll be there, and and Cisco's going to be doing pancake breakfast and a day of podcasting. What are some of the topics that you guys would be interested in talking about things that are kind of trending, discussions that you're interested in? I'm curious from your guys' perspective.
I can go first. So one of the big things with CNI that we were interested in the community together is looking forward. I'm working on with a few of these networking vendors is, like I said, CNI is a host local standard. It's a host local configuration, but who has the global cluster-wide state view? So we're working on with the community. We'll probably work with the CNI community to donate it with the CNI repo to see if we can have some kind of configuration service, a CNI configuration service. So I can go and do, CNI config create red network. It creates a config file for every 1,000 hosts, distributes it on all of the 1,000 hosts, implements health checks and makes sure that its integrity is valid. So you can have a cluster-wide CNI network or cluster-wide CNI configuration distributed. So that's something from a CNI community we're looking forward to it. Also evolving the CNI spec to be more richer, to do kind of service chaining. Some of the richer kind of semantics, which you don't need day zero, but as this community and the container ecosystem matures, that thing will come in. So those
are some of the semantics that are, that are being sought.
The semantics, there's some semantics around, I'll go to the first one, cluster-wide kind of CNI configuration deploy. Some of the challenges there is, how do these plugins register that I support cluster-wide kind of deployment? Maybe I'm a very dumb CNI plugin because it's so flexible. I only support only local bridge mode kind of plumbing the container. So how do you make sure that they can register with the configuration service? How can you make sure that these plugins are actually alive and health checked, so not one of them is down? Or if one of them is down, that take that host out of rotation, make it easier to troubleshoot. So that's one of them. And from a service chaining perspective, we need to figure out what is the network interface where the services can chain itself and insert. So that's pretty early on. So that would be the main thing, is that where is a tap device, if you will, where the third-party services can insert into a CNI-powered network.
So that's the programmable infrastructure you're talking about.
Well, CNI is about the standard, but it has to have some kind of programmable infrastructure linked to this kind of the CNI tap device equivalent or that service chaining insertion point. And those are kind of open questions we need to figure out in the CNI community.
Yeah, just to add to that, we kicked off a project about a year ago called FDIO for fast data. And how do we sort of offload? FDIO sort of, plugs in right in, leverages CNI, but also can plug in right into Linux hosts and give you the ability to do high performing, line rate networking and routing. And it also, to the point we were just talking about with service chaining, we've been adding a lot of firewall and network address translation capabilities into FDIO. And so some of the basic networking components that you would expect to have, IPv6 is another one, IPv6 and IPv4 to IPv6 translation. So a lot of the network function components that you need in a truly networked aware service environment, we're trying to add to the FDIO project. And that works with the CNI interface. It also works natively in Mantle.
That puts us up at about a half hour for the conversation here. So I think that's probably a good place to stop. Thank you guys both for taking the time to be with us. Somik and Ken, appreciate your time. And Joab, as always, thanks for being the co-host. And we'll be back again soon for another episode of the New Stack Analysts.
Thanks, everyone.
Thanks, guys.
Thanks.
Thanks to Cisco for sponsoring this episode of the New Stack Analysts and our continuing coverage in advance of KubeCon, the conference for the Kubernetes community happening in Seattle this November. Check out Mantle, the open source microservices infrastructure. Mantle runs containers on any cloud service, integrates data platforms such as Cassandra, Spark, and Hadoop, provides ways to deploy and manage infrastructure with tools such as Terraform and Ansible. Learn more at mantle.io. That's MANTL.io. Please also join us for podcasts, Pancakes and Robots for our Pancake Delect Pancake Breakfast on November 9th at the KubeCon conference. Thanks to Cisco again for making it possible.